So what we're going to finally look at here in regards to some different things with trig functions in quadrants 2, 3, and 4 have to do with some other things that involve not using calculators and some other things with obviously with using calculators. So the next example here is something that we're going to use. We're not going to use a calculator for. So the question here says to find two solutions for each equation. So give your answer in degrees and radians. So what we're looking for here is what's the value of theta if the sine of theta was 1/2. So if I was talking about not using a calculator for this, if I come back to my triangles here, so anytime we're talking about sine, cosine, tangent and not using a calculator, most often we're talking about something that's going to involve a right triangle that's either a 45, 45, 90 or a 30, 60, 90. So let me kind of just put these once again off to the side here. So I got 1 root 3 positive 2. So to do the sine of theta equals 1/2, if you notice in your 30, 60, 90 triangle, if I did the opposite divided by the hypotenuse here for a 30-degree angle, that would have a sine value that's 1/2. So that tells me right off the bat that one of the values of theta is 30 degrees. So remember what we know as far as the sine goes and what quadrants the sine is positive in. So we know that the sine is positive in quadrant 1, which is what this angle is here, but we also know that the sine is positive in quadrant 2. So if I were to draw a 30-degree reference angle in quadrant 2, so if I were to draw a 30-degree angle like this here, what I would basically want to know is this would be theta prime, and what I want to know here is what's the value of theta. So if this angle here is 30 degrees, that means that this angle here would have to be 150 degrees. So that's the other value of theta here. And one of the things that I can do with my calculator to check to see if I'm right is if I did the sine of 30, once again if I was in degrees, if I did the sine of 30, that would equal 1/2, and if I did the sine of 150, that would also equal 1/2. So keep in mind that the question also asked you to take your answers and write them in radians. So 30 degrees, remember, in radians would be pi over 6. And remember, you simply just take, to convert that to radians, you simply multiply it by pi over 180. And then if I take 150 degrees and convert that to radians, that ends up being 5 pi over 6. So same thing there. Remember, to go from radians to degrees, or degrees to radians, you're just multiplying by pi over 180. So that's part A there. Part B, I'm going to do the same kind of thing here, but notice with this, it's the cosine of theta equals root 2 over 2. So I'm going to draw myself a little 45, 45, 90 over here. 1, 1, square root of 2. So remember that anytime you have the cosine of a 45-degree angle, this would be 1 over root 2, and remember 1 over root 2 is just root 2 over 2. So that tells me here that one of the values of theta is 45 degrees. But remember, the cosine is positive in quadrants 1 and 4. So this angle's in quadrant 1. If I were to draw a 45-degree reference angle in quadrant 4, so if I had something like this here, so if this angle right here were 45 degrees, what I would want to know is what's the degree measure of this angle here. So for this particular angle, this is going to be 315 degrees. So that's the other value of theta here. And here's the thing, if I were to do the cosine of 45 degrees in my calculator, I would get root 2 over 2. If I were to do the cosine of 315 degrees in my calculator, I would also get root 2 over 2. And then once again, converting these to radians, 45 degrees in radians would just be pi over 4. 315 degrees in radians would just be 7 pi over 4. So just remember, degrees to radians, you're just multiplying the degree measured by pi over 180. So that's part B. And then part C, I have the cotangent of theta equals negative square root of 3. So if you recall the 30, 60, 90, that's the only one of those two triangles that has square root of 3 in it. So here I got my 30, 60, and a 90 here. So remember the ratio of the sides here are 1, root 3, positive 2. So remember cotangent, remember tangent I can find by doing the opposite over adjacent. Cotangent I can find by doing adjacent over opposite. So with this here, cotangent would be adjacent over opposite. So with this one here, if I take the 30-degree angle, the adjacent side is square root of 3, the opposite side would be 1. So that would tell me that the cotangent of theta would be 30 degrees, but since this is negative here, we're talking about theta being negative 30 degrees. So if you notice here, we want angles that are somewhere between 0 and 360. So if I found the coterminal angle for negative 30 degrees, if I added 360 degrees to it, I would get positive 330. So that is the angle for the cotangent that's in quadrant 4. But remember that we know that tangent and cotangent are negative both in quadrant 4 and in quadrant 2. So if I went to quadrant 2 and drew a 30-degree angle in quadrant 2, or a 30-degree reference angle, excuse me. So if I made this angle here 30 degrees, what would the degree measure of this be here? So since this is 30, that would make theta equal to 150. So that's the other angle, in this case in quadrant 2. That's a second solution to this. So if I did the cotangent of 330 degrees in my calculator, that would equal negative square root of 3. And if I did the cotangent of 150 degrees in my calculator, that would equal also negative square root of 3. So those are some different things with sine, cosine, tangent involving the 30, 60, 90 and the 45, 45, 90 triangle without using a calculator. So here's some different things where we are going to use a calculator, and it says here for the next part, use a calculator to approximate two values for theta that satisfy the given equation. So notice here I have the sine of theta is 0.4257. So sine is positive. So remember the sine for theta is positive in quadrant 1 and quadrant 2. So this value of theta has two different angle measures, one in quadrant 1, one in quadrant 2, that's going to make this statement positive. So if I take my calculator and I do the second tangent, make sure I'm in degrees here first, which I am. So if I do the second tangent of 0.4257, I get an angle measure that's roughly 23 degrees. So that's going to be, or we're going to 3 decimal places for this, so this would be 23.059. 23.059. So that is the angle measure for quadrant 1 no, wait a minute, I did tangent, supposed to be sine, my mistake here. Let me try that again. So I got second sine of 0.4257. So when I do that, okay, I got 25.195. Okay, so that's the one solution to this problem here. So that's in quadrant 1. So the other solution to this is in quadrant 2. So if I go to quadrant 2 here and I draw an angle that's a reference angle that's roughly about 25.195 degrees. So if I did something like this here and I made this angle here roughly 25.195 ... degrees, what would this measure be here? So remember, mathematically to find this, what I want to do is I want to take 180 minus this value here. So if I do that in my calculator, sort of take this out, so if I did 180 minus this value here, that's going to get me the second solution to this here. So that's the two solutions there for part A. For part B, I have the tangent of theta equals 4.812, and notice we're talking about finding the two solutions that are in radians. So with this one here, what I want to do first with my calculator is I want to turn this back into radian mode. So let me come down to here. I'm going to put this in radian mode. So what I want to do first here is the second tangent of 4.812. So that's going to get me a radian measure. If I go to 3 places with this, this is going to be 1.366. 1.366. So now, if you notice, with the tangent being positive, remember that the tangent is positive in quadrants 1 and also in quadrant 3. So if I went and drew a reference angle here that was 1.366 radians in quadrant 3, so I might get something that's like down here like this. So what I want to know is, what is the measure of this angle here? So keep in mind that from here to here is pi in radians. So what I want to know is, what is it from here to here? So if I just take this answer, this one here, this 1.366 radians, and I just subtract pi from it. So let me see here with this. I'm sorry, not subtract pi, add pi to it. So if I take, let me exit out of here. So if I take my answer here and I add pi to it, that's going to get me what the angle in radians is in quadrant 3. So if we're going to go to 3 places with this, this would be 4.507. 4.507. So that's the answer for part B. And then finally, finishing up with this last example here. And the question says, find the indicated trig value in the specified quadrant. So for part A, what we have here is the sine of theta equals -4/5, and it's in quadrant 4, and we want to know what would the tangent of theta be if that were true. So if I draw an angle in quadrant 4, so I get something like this here, and if I draw a reference triangle for that, so here's my right angle. So just remember that sine is y over r. So if I have -4/5, that's going to make this -4, that's going to make this +5. So what I want to know here to find what the tangent is, remember tangent is y over x. So I got to know what the x coordinate is here. So if I did Pythagorean theorem here, if I did, let's say, x squared plus -4 squared equals 5 squared, if I solve that for x, I get x equals 3. So that's going to be here. So then the tangent of theta for this is going to be the y coordinate divided by the x coordinate, which in this case would be -4/3. So that's the answer for part A for that one there. And then for part B, I have the secant of theta equals -9/4. That's in quadrant 3. What would the cosecant of theta be? So if I drew an angle in quadrant 3, which is going to put me somewhere down here, and here's my reference triangle that goes with that. So remember that secant is the reciprocal of the cosine. So if cosine is x over r, secant is r over x. So when I put these values in here, that's going to make the hypotenuse +9. That's going to make the x coordinate -4. What I have to figure out is the y coordinate, because the cosecant is r over y. So to find the y coordinate here, I'm going to do x squared, Pythagorean theorem, plus y squared equals 9 squared. So when I solve this, I get y equals the square root of 65. So now when I go to do the cosecant here, I'm going to take the radius over the y coordinate, but just remember with the y coordinate here, because I'm in quadrant 3, that's going to make this negative square root of 65. Remember, the y coordinate is negative in quadrant 3. So when I rationalize the denominator here, this is going to be -9 root 65 over 65. And that's the answer to the last example there. So that pretty much covers a lot of the different things that we're going to at least initially look at here with sine, cosine, tangent involving angles that are not just in quadrant 1, but also angles that are in quadrants 2 through 4.